histogram. What it does is that it is a pictorial representations of informations. Then I will use a question to demonstrate exactly how we can use informations to represent in the picture form and exactly how it looks like. You are given a table shows the height of trees. Okay, so now the first part says that you should draw a histogram. If you don't know what a histogram is, I will demonstrate that by solving this question. Now these are the heights of the trees, right? You have the trees here, so these are the heights, and then these are the numbers of trees that have this type of height. Let's say you have a height of 2 meters, right? 2 meters. How many tree in your farm, right? On that farmland, that's what the height of 2 meters. So I think we have a 14 numbers of tree on the farm, right? That's what 2 heights. And then for 3 you have 21, for 4 you have 42, and so on and so forth. Is that okay? And then the first part is that you should draw a histogram. For you to draw the histogram, you need 2 things. For this type of question, you need just 2 things. Is that okay? You need those who will be on one side of the graph, and then those will be on the other side of the graph, says x and y axis. So let me use this graph to explain that. Simple. Now let's say this is just a graph to demonstrate how you go about this type of question. Well, the first thing you have to do is that you have to make sure that you know the numbers at your disposal. Saying you have to know which people will be on this line, right? Which people will be on this line, and then going this way, which people will also be on this side of the graph. So it's a graph that we use to draw the histogram. Okay, now when you look at the information that you are having, you can see that the number, you have 2 type of numbers, the one with the height as well as the one with the numbers of tree. So the one with the height will be on this line. Is that okay? So the one with the height will be on this line, right? So here will be the height of the tree. That's the 2, 3, 4, 5, and so on. But how? Where exactly are they supposed to be? That is what you have a look at in just a minute. And then the one with the numbers of what? The tree. Let's say 2. The first part says that the tree with height 2. How many are there? There are 14, right? Those 14 numbers will be on these houses. Is that okay? 14, 21, 42, 83, and then 1, 1, 2, 12, 7, and 3 will be on this line, right? So we call them what? Frequencies, right? We call them frequencies. So the frequency will be on this line. What I mean by the frequency is that, let's say in your class, we need like a number of people who are 15 years, right? Who are 15 years. Is that okay? Let's say in your class, we need a number of people who are 15 years of age, right? Who are 15 years. So let's say in the whole class we got 4, right? So this 4 will be the frequency, right? This 4 will be the frequency. Is that okay? And then this will be the raw data that we are dealing with. Okay, so the number will be the frequency. So the frequency will be on these axes. So we call them what? That is what? The y-axis, right? So this side will be what? The y-axis. Is that okay? And then the down here will be what? The x-axis. Now the first thing first, the numbering here depends on you. So you just have to look at the smallest number and what the largest number among the information being given to. So here we know, now that we know that the numbers those who are supposed to be on these houses, then we know that the smallest among them is 3, and then the highest among them is what? 18 from the question, right? Sorry, 118. So 118, right? When I look at my table, you can see that the smallest one is 3, and then the largest among all these numbers is 3. So this is I think 6. A tree that has a height of 6 meters tall are 180. So these people are more, right? So you just have to look at the numbers and then come here and come and do the numbering. So how do you do the numbering? So you can decide to count first. Is that okay? You can decide. Let's say someone say the person is going for 5, 10, 15, 20, 25. So you can see that you are not going to get the last number, which is 180, right? So the naming here depends on you, right? The numbering depends on you. So I will go for 10, 20, 30, 40, 50, 60, 70, and so on and so forth. You can see that my last number here, the last number here is 120. Of course, I can get 118 out of that, right? And then the down, the smallest number here is what? Is what? 10. Below the 10, I have some space here, so out of that I can get 3 and the 7. Is that okay? Okay, perfect. Now on these answers, I will advise you to take some time because of this question, right? Just advise you to take a time. And all I have to do is that you count the numbers of the columns that you have. What I mean by the column, how many numbers or how many things are we dealing with, right? How many things? So from the question you can sort of, let's say this is 1, 2, 3, 4, 5, 6, 7, 8. In all, we are having 8, right? Meaning that the bars that we are going to get here are 8, right? Meaning that the bars that we are going to get here are 8. So if you decided to count from here, right, from here to here is 1 bar, right? So from here to here will be what? 2 bars, 3 bars, 4 bars, 5 bars, 6 bars, 8 bars, right? And then 9 bars, right? That is okay. Is that okay? So when I decided to start from here, so taking this one to be 1 bar, that is okay. I can get all the bars over here, right? Okay, now perfect. How do you start? You start with the first one that says a tree with a height of 2 meters are what? 14. So if you start from here, you just need to locate what? 14. So 14 on your graph. This is 10, right? Just count. So one bus here is just equal to, let's say, 2, right? So because 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10. So if here is 11, 10. Here is 10, right? Here is 10. Can you see? Here is 10. So the smallest box is here: 10, 11, 12, 13, 14, 15, right? 16, 17, 18, 19, 20. Exactly where you are. So each small box is just what? 1. Is that okay? Each small box is just 1. So if I'm here, so I'm looking for 14. So this is 10, right? 10. So 1, 10, 11, 12, 13, 14. Here. Is that okay? Here at this point, right? I'm here, so here will be what? For the first bar. Is that okay? So this is for what? Just the first bar, right? So let me draw that line and show you exactly how you have to do it, and come back and show you what I've done. So this is what I've done so far, right? So we are on the 14, so meaning that from the 14, after we counted, we got to the 14 here, which is here. So we are using this box to represent the trees that are 2 meters tall. They are 14, right? So from here to down, they are 14. So here we can write here at the middle. Look at what I'm writing. I'm at the middle here. That is 2, right? Meaning that the trees that are 2 meters tall is this one, right? From this side. Is that okay? So you can decide to shade this one nicely, just to show some differences, right? Just to show some difference so that you can see clear. Okay, now the next one, the next line, you have 3. That is what 3 meters trees are what? 21 in our farmland, right? So 3 meters tree are what? 21. You just have to look at what was happening here. Will be from here to here will also be another portion, right? So here you just need to locate what? 21. So 20, this is the 20 line, right? This is the 20 line. So if you count maybe 20 from here, then 21, just one box. We know that one box is equal to 1. So here we got 21. Then you draw your line perfectly, nicely, right? You draw them. Now the same we have to do for each of what? The categories. So here each of the trees, right? And draw a line perfectly. Remember, in histogram there is no space in between, right? We don't have a space. So from here you move to the next one, and so on and so forth. So let me finish up and show you exactly what I've done. After you've solved everything, this is how your graph should look like, right? You can see from the question that 2 meters height of tree are 14, right? They are 14. So okay, 14 on this one. Then 3 meters height of trees are what? 21. So 21 here is what? Yeah, right? You see this is 20, this is 21. Okay, and then 4 meters out of 3 are what? 42. So 42, this is where 40 is, so you just need to count 2 ahead of that. So this is a 40 and then 42, right? So the same thing you have to do for the rest of your graph. So this is how your graph should look like, right? Very nice graph. Okay, so this is what we call what? A histogram, right? A pictorial representations of what? Information, right? So this is somehow nice. Even if you're not a mathematician, when someone interprets this thing to you, you can see what is happening. Even with this one, you can answer most of the questions, right? So let's say which trees has what? The largest number in our farm, right? On that farmland, which tree has the largest number? So you can see 6 meters tree are tall, right? When you look at the graph very carefully, you can see that 6 meters trees are tall, right? So you have how many are there? 118. So look at this one. So my graph ends at 120. So 118 is also 2 counted down, right? So just 2 they are here, right? Okay, so this is what we call what? A histogram. Histogram has no space in between, right? They have no space in between them. And this type of question, you should know exactly what it's a number. So you see that my number are at the middle, right? Because we are dealing with just one single numbers. Is that okay? Okay, so perfect. Now the next question says that we should let me check that. So we should find the mean, right? We should find the mean of what? This type of information. What is the mean? The mean is the what? Average, right? The mean is the average. Okay. Now the question says you should find the mean for what? The distribution. You see, you have to know who is the mean or what is the mean first before you can find it. Just assuming I asked you to call me let's say any name here, let's say Joseph, right? I asked you to call me Joseph. If you don't know Joseph, how can you identify the person? So first thing first, you have to know what exactly this mean is. So the mean here is that this is the tool that you use to solve the mean. So this is how we can identify the mean. So with this type of question, you have to use this tool, right? The reason is that you see the information that we are having here are being grouped. So maybe let's say, you see what I mean by the group is that it has been arranged, in my opinion, right? It has been arranged. So consider from 2 you move to 3, 4, 5, 6, 7, 8 and 9, right? Everything has been arranged. I'm not talking about the frequency. The frequency may change because the frequency are the number of the things that are appearing in our garden, right? So this is what I'm talking about. So from 2, 3, 4, 5. So everything has been arranged. With the mean, we have different types of mean. So with the group 1, if you know that the information has been grouped, as I said earlier on, this is what you have to use, right? If it is no group, that is a different case altogether. Every tool has what it does in this word, right? Just like cutting an onion, you are chopping some onion, you have to use the right tool to chop that. Okay, now this is the information that we are having, and then so if you find the mean is this is what you have to use. It is your duty to know exactly what they are. So if I want to read this thing is what the summation, right? Sigma fx over sigma f. So what this thing is, this one stands for summation. The meaning of the summation is adding. We are adding, right? We are adding. What are we adding? We are adding everything here. We are adding fx. Right, this f here is the frequency and the x is the raw data that we are dealing with. What I mean by the raw data, this is what our raw data, right? This is the raw data here, right? 2, 3, 4, 5 and so on and so forth. So this is the x. You should in mathematics to apply any formula, you have to know where the numbers or these members are coming from, right? Once you're able to do that, you are free to go. Okay, so I say this stands for what? Summation. This is the frequency and what this is what the f. So what is this thing that do is that maybe this sigma here, the functions of the sigma is to sum. To sum what? To sum everything that comes after what? Or anything that is in front of what? The sign here, right? So anything, what is it? We have x first, meaning that f is multiplying x, right? And then the down here you have what? F, only f, the summation of s. Let's add in all the f, right? Add all the f, add all the f. Here you are going to add fs. Now, do you know fs? You don't know fs, right? Do you know f? Of course, you know f. So here is f, right? After summing, you got F stand for the frequency, right? After summing, they say you should sum, you should add everything here. So that would be what? 14 plus 21 plus what? 42 plus 83 plus 180 plus 12 plus 7 and then plus 3, right? So that is the function. This is summation of F. Summing all F, summing all F, adding all F. So when you add everything, it will give you 300, right? Now what about the top? The top, the summation of what? All Fs. What is means that F multiplied by S. So where is the F? And then where is the X? So what I have to do is that you have to look for that, right? You have to look for that. So this is my X and this is my F. So let's multiply them. So 2 multiplied by 14, that is what? That is what we are calling what? Fx. So F multiplied by what? X. So 14 multiplied by 2, that would be what? 28. The same thing that you have to do here. So this multiplied by that, right? So this multiplied that will give you 63. You have to do for everything. Then when you are done, you sum, right? You add them. So addition of what? Fs. What are this guy? One guy is Fs. This is Fs. This is Fs. This is Fs. This is Fs, right? They say the function here says you should add all Fx. So when you add everything together, when you add 28 plus or 63 plus or 168 and then so on and so forth, then you arrive at 1549. Is that okay? Comment down below if you are having a different answers. If you enjoyed the video, you may consider subscribing to the YouTube channel so that you don't miss any content like this. Now let's get back to our question. They say you find a mean. This is the two. Now we know this guy, we know that guy. We just have to exchange them, right? So this guy is what? 1549 divided by 300. When you do this thing nicely, you get something like 5.16 meters. Is that okay? And then the question says you should round down to the nearest meters. So how do you do that? How do you do that? You just check the number just after the point. We call this guy decimal point. If it is 5 or more, you convert 1 to that. But if it is less than 5, right, you leave it as it is. Of course, this one here is less than 5. Just the one digit. The number after the decimal point is what I'm talking about. This is less than 5, so we leave it as it is. So now here becomes what? 5 meters. If you want to know more about this thing, just subscribe to the channel. You have a topics on that where we solve numerous questions for you to understand better. Okay. Now the next part of the question says that you should find the probability, right? The probability of what? At least 6, right? At least. So one thing you have to understand that is you need to know this before you can move on. At least 6. What does it mean? When they say at least 6, it means that from 6 going up. Is that okay? So at least 6 means that from 6, you are going up. You are not coming down. From 6, 6 is bad. At least 6. And then the other one is so at most 6. At most, okay, that will be for another topic, right? So at most means that from this guy down. Is that okay? So they say you should find a probability. Now you also need to know what a probability is. What exactly is a probability? The chance, right? The chance that what? So at least 6, right? At least it's meaning from 6 going. So just look at the table that we are having here. So this is where I'm having the 6, right? At least 6 meters and above, right? 6 meters and above. What I mean by the above here, not here. At least 6 upward. So from 6 we move to 7, 8 and so on and so forth. So at least 6. So this is what? 6 what? Meters. And then 7 meters must be part. 8 meters also part. And then 9 meters also part. But we are not dealing with the raw data. How many people how many trees on our garden are 6 meters? 118. Right? How many are 7 meters? 12. So you need to add this guy. Okay, you need to add all of them. So that will be 180 plus 12 plus 7 plus 3. So when you sum everything together, you have what? 140. Now let's answer the probability. So the chance, so 140 over the total number of the trees that we have on our garden, that is what? 300. So 140 over 300 will give you 7 over 14. So you convert that, you have 0.47. Right? So that is the probability that we are talking. So this is the first part of the question. If you enjoyed the video, subscribe to our YouTube channel for more content like this.